I'll go with the addition or elimination method is to make it so that one of the two variables will be equal and opposite such that when the equations are added, that variable will drop out. The first example, A, has a situation where I already have an equal and opposite variable. Specifically, this negative 1x and this positive 1x are equal and opposite. So I can just jump right to the stage where I'm adding these two together. Y minus x equals 2. I'm going to add to y plus x equals 8. This is 1y being added to another 1y for a total of 2y. This is negative 1x being added to positive 1x, which was our goal, to have things that were equal and opposite, that would then go away. On the right hand side, 2 plus 8 gives me 10. If I now solve for y by dividing by 2, I get y equals 5. I can put that y equals 5 into either of these two equations. I'm going to choose to put it into the bottom equation. So I'm going to get 5 plus x equals 8. If I then subtract 5 from each side, I get x equals 3. Now that I have the value for x of 3, I want to plug it back in to find a value for y. Oh, I'm sorry, I already found the value for y. So now that I have x equals 3 and y equals 5, I can write it as an ordered pair, 3, 5 is my answer. Same idea in part B. They've already given us something equal and opposite, specifically positive 2y and negative 2y. So if I just write them over top of each other, 2y plus x equals 6, and negative 2y plus 3x equals 2. When I add the y's, they go away. Understood 1x plus 3x gives me a total of 4x. 6 plus 2 gives me a total of 8. If I divide each side by 4, that's how I get x equals 2. I could plug it into either equation. I'm going to plug it into this one. So it tells me that 2y plus 2 equals 6. If 2y plus 2 equals 6, then I can subtract 2 from each side and get 2y equals 4. Dividing each side by 2, that would give me y equals 2. So I have x equals 2, y equals 2 as my ordered pair, which I would write as 2, 2. In C, I have the first situation where I don't have equal and opposite from either letter. So I want to think which would be easier to eliminate. The reason that x would be my decision is because this has 1x, which is much easier to manipulate to be equal and opposite to this positive 2x. Specifically, I can just multiply this whole top equation by a negative 2. I could have made the y's equal and opposite, but in order to do that, I'd have to multiply both equations. Top equation by 3, bottom equation by 2. So I'd rather do something that only makes me multiply once. If I multiply the top equation by negative 2, I'm doing negative 2 times x minus 2y equals negative 2. Negative 2 times x gives me negative 2x, which was my goal because it's equal and opposite to this 2x in the other equation. Negative 2 times negative 2y gives me positive 4y. Negative 2 times a negative 2 gives me positive 4. So I've now multiplied each part of the equation by the same number, meaning I haven't changed the equality at all. With this equation and the equation that I already had as the bottom equation, I now have two things that when combined will get rid of one variable. Specifically, 2x plus 3y equals 3, and negative 2x plus 4y equals 4. When I combine these, the 2x's go away, as was what I intended by the elimination method. 3y plus 4y gives me 7y, and 3 plus 4 gives me 7. If I now try and get y by itself, divide these each by 7, and I get y equals 1. I'm going to take that 1, and I'm going to plug it in everywhere where I see a y in this second equation. So 2x plus 3 times 1 equals 3. 2x plus 3 equals 3. Minus 3 from each side, and that gets me to 2x equals 0, which means that x equals 0. So I have the point y equals 1, x equals 0. I want to make sure I'm writing it as x comma y. So 0 comma 1, even though I solve for y first and x second. In parts D and E, I'm going to need to do some distribution, take x's and y's to the left, numbers to the right, before I can really start the addition. You may have noticed that this fourth problem changed slightly down here from what it was a moment ago. That's the magic of the camera trick. Basically, I started to solve out the way it was, realized it was an incorrect problem that didn't get me to an answer unless I had a bunch of fractions and mixed numbers flying around, so apologies. I'm cutting in, I'm changing it to something that you should be able to solve. That said, what I need to do to begin with is distribute in each of these problems, get it in a form of y's, x's on the left, and numbers on the right. So, to begin that process, I'm going to distribute this 3. The top equation is going to become 4y plus 3x plus 3 equals 8. If I then subtract 3 from each side, I get the equation 4y plus 3x equals 5. For this second equation, I'm going to distribute that negative 2. If I distribute that negative 2 times y, I get negative 2y. Negative 2 times negative 2 gives me plus 4. And then on the other side, I have 2x. I can subtract 4 here, subtract 2x here. That brings things to the other side. I still have negative 2y. This positive 2x that I subtracted negative 2x from each side creates a negative 2x here. And then this negative 4 is on the other side. I now have 2 equations, but I don't have anything equal and opposite. In order to get these equal and opposite, I'm going to concentrate on the y. I see this as a positive 4y. To make this into a negative 4y, I just multiply this whole equation by 2. So what that means is I now have 4y plus 3x equals 5, and negative 4y minus 4x equals negative 8. If I combine these lines, the y's go away. Positive 3 and negative 4x leave me with negative 1x. Positive 5 and negative 8 leave me with negative 3. If I multiply this by a negative 1, it leads me to x equals 3. Now that I have a value for x, I can plug it back into any equation to solve for y. I'm going to plug it back in here. So I get 4y plus 3 times 3 equals 5. That gives me 4y plus 9 equals 5. If I subtract 9 from each of these, then I get 4y equals negative 4, which means y equals negative 1. So I get the point x equals 3, y equals negative 1 as my solution. For part E, same idea. I'm going to start by distributing, making sure all the letters are on the left, all the numbers are on the right. So when I distribute this 3, I get 3y minus 6 plus 3x equals x. I'm going to take this 6 to this side. I'm going to take this x to this side. So plus 6 here, minus x here, minus x here, plus 6 there. That gives me the equation 3y plus 2x. I'm getting the 2x as the 3x minus x equals positive 6. Now that I've done that to the first equation, I need the second equation to be done out. 2 times x is going to give me 2x. This 3y is still already here. 2 times 3 gives me a positive 6. To move it to the other side, I subtract 6 here, subtract 6 here. 12 minus 6 gives me 6. At this stage, hopefully you can recognize, wait, I have literally the same thing written top and bottom. When I have the same exact thing, it's going to mean that when I try and eliminate a variable, everything gets eliminated. So if I wanted to multiply this bottom equation by negative 1, you'd see what happens is I get 3y plus 2x equals 6. And on bottom I get negative 3y minus 2x equals negative 6. When I combine these lines, 3y and negative 3y give me 0, 2x and negative 2x give me 0, 6 and negative 6 gives me 0. So I literally get nothing on this side, and I get nothing on this side. That's a true statement. When we're doing either the substitution method or the addition elimination method, and our variables knock out of the equation like they did here, when both variables are gone, a true statement means dependent, a false statement means inconsistent. In this case, 0 equals 0 is true, so I would write dependent.